We go through the hydraulic dyno and test stand. Get the main stand, which is basically a pressure and flow source. We got a VFD driving a 30 horsepower electric motor, so we get some speed control on that. We're running it at 20 hertz, so a third of full speed, to a 12 cc fixed displacement pump. And the pump outlet is hooked to this unloader valve, which just goes back to tank so we can unload the motor. The other trunk goes to a check valve into the accumulator, which can be taken in or out of the loop, and then up to the main pressure trunk here, where we can hook up valves and do flow and pressure control out to motors or whatever else we want to test. So what I'm testing today is the pressure drop across this pressure control valve. So basically I'm looking at accumulator pressure here and outlet pressure here to the motor, and the motor's hooked up with a K-string coming off vertically off the top. It's shaft coupled to a gear pump, and we got a speed sensor on that shaft. The gear pump just pulls fluid from the reservoir and then out through a throttle back to the reservoir. So it's just there to be able to, by changing the throttle position, we can change the pressure on the outlet, which is directly proportional to the torque that is being input to the gear pump. And then on the software side of things, we got a panel here that Jonathan Reynolds put together in LabVIEW. On the left hand side, the dial is RPM. That's how fast the motor and gear pump are turning. We've got the torque, which is calculated off the pressure at the outlet of the gear pump. We've got the accumulator pressure on top, motor pressure, and gear pump pressure there. These sliders here adjust the pulse width that goes to the control valve. So if I set this to a 40, you'll see on the scope that should come up, but I'm not even running it. So there you go. See that pulse width, and then the motor control valve is set up to ramp up. So you'll see that pulse width start to move. Now they're having some effect on each other, and they're both inverted. So anyways, we'll pressurize it up and then record a run.